Good morning. Welcome to today's lesson on linear equations. We're going to talk a lot about linear equations. We're going to have many discussions. We're going to graph them. We're going to write them. We're going to rewrite them. We're going to rewrite them again. We're going to transform them from one form to another. We're going to write our own equations based on graphs. We're going to do graphs based on equations. We're going to do a lot of things with linear equations. But let's start out with basics. Okay, we got a lot of vocabulary. Got a lot of things to understand before we can even talk about doing all those things that I just mentioned. So let's start with what is a linear equation? So linear equation. So seems fairly clear that the word linear has this word line in it. So we're going to be drawing, this is all about straight lines, no curves, no arches, nothing. Straight lines, okay? All different types. We'll talk about the different types in our next lesson. But for now, we're just talking about lines. And an equation means it has an equal sign in it. We saw just in our previous video, we were doing things with inequalities. Now we're talking about equations. So we're back to something with an equal sign. So a linear equation is, it's terrible to say this, but it's the equation of a line. And it is a description of all of the points on a line that we can see on a graph. So when we're looking at the graph of a line, we can see this represents all the points. Okay? And what do I want to say about that? So, how does it look? There's a lot of different ways that it could look. Okay, and we're going to talk about that a little bit later. I think the most important thing is that for the most part it has an x and a y. So we've been solving all these equations with one variable in them. Now we're suddenly going to see equations that have two variables, an x and a y. That doesn't mean they have to. There are special cases that have just the x or just the y, but we're going to spend a lot of time talking about the ones that have both. Probably 95 or more percent of the time, we're going to be looking at ones that have both an x and a y. Okay, so next up on our vocabulary, since I've just mentioned x and y, are domain and range. Okay, these are very specific words. They have a very specific meaning when it comes to graphing. The domain is also referred to as the input variable, meaning it's the one that you are plugging in. You know it. Okay? I know I want it to be 4. Then you see what happens. Okay? It's the domain, the input variable, it's the x coordinate when we talk about ordered pairs and linear equations. Okay? Because we're going to be talking about a lot of those ordered pairs. Okay? X's and Y's together. Okay? The domain, the input variable, the x coordinate. Really, just for the simplest sake, it's x. So when you see tables, and we're going to see them in your homework, we're going to see them in later notes, we're going to see them all over the place, the x is the domain. Well, I think it makes it clear what the range has to be. The range is actually called the output variable. And it's, well, if I know what x is, then when I put it into the equation, I get a y value out of it. I get an output variable. Okay? Kind of like if I know how fast the car is going, if the input variable is how long did you drive at that speed, then you know how far you went when you got there. Okay? If you know how much money you're making per hour, that's the input, then you can know how much you made after working a day. Input, output. It's also the y coordinate. Coordinate. It's the y value. We're going to see a lot of equations that have an x and a y. That's the linear equations, okay, the x and the y. So And they'd be written like this: x comma y in a parentheses. So again, this being the domain, and this is the range. The nice thing here is it's just alphabetical. If you ever get a little twisted up and you're not sure, domain, D comes before R, X comes before Y, input comes before output. They pretty much follow the rules on alphabet every time. So if you're not sure which one you're looking at, just think where it is in the alphabet compared to the other possibility. Domain before range, input before output, X before Y. Okay, so, and we're going to do some problems where they're going to present you with, here's the domain, and then they'll say, like, find the range, or, and they do this all the time. There's lots of, like those examples I gave you of, the domain is, this is how much you make per hour, the range is how much money you make in a day. Okay, the domain is how fast you're going per hour, the range is how fast you went in 5 hours, for example. Okay? So domain and range, mostly I'm going to talk about X and Y, probably far more than domain and range. I'm going to let that go almost immediately. Like within a week, I'll stop saying domain and range. But you should know what it means if it ever comes back up. And it will come back up, is what I'm saying. Okay? All right. Now, another aspect of linear equations is the word function. Okay, what is a function? So let's say, what is a function? Okay, I can give you a very textbook definition, and I'd rather not really dwell on the exact textbook definition here too much. Okay, a function is any relationship between an x and a y where there's one x for every y. And that's it. Okay? Now, I think a better thing to do for us in this situation is not to figure out what the textbook definition, but really just how to identify, is it a function? They love, I don't know why, but they love to ask this question. This is one of the new things that has become rather common in end of course exams given by the districts and college entrance exams is this a function? Tell me which one of these is a function. Honestly, it's not that important, but they love it, and I want to make you ready for it, so here it is. So the question is that you're going to be seeing is it a function? Question mark. Well, there are two ways to tell if something is a function. And they're very simple. Two ways to tell. First, does the domain, which we know is x, have the same number more than once? That's the question. Does the domain appear more than once? Okay? If yes, no function. If no, then it is a function. In fact, let me give you a better question, because that's the real question. Let me give you a better question. Okay? So it's still the first way to do it. Does the domain repeat? Okay? I mean, does it appear more than once, right? Does it repeat? Because if it's yes, then it's not a function. If it's no, it's a function. Let me give you some example. I'll give you two examples. I'll show you what I mean. So we have a list of points. 1, 2, 3, 4, 5, 6. And I say to you, is this a function? And all you do is you look at this number, the first number. That's the domain of each of these ordered pairs. Are those all different? Yes. Then it's a function. In fact, just what I said. Let me even change this one more time. Are all the numbers in the domain different? If you can say yes, then it's yes. It's a function. If you have to say no, they're not all different because I see the same one twice, then it's not a function. So an example of that would be 1, 2, 3, 4, 3, 5. Because here we see 3 and 3. Now, I want to make sure you understand it's the domain only. I do not even need to know what this number is. I don't even care what that number is. And it doesn't matter if that number is in the next one. So if I jump back up here where we know this is a function, if I change this number to a 2, it's still a function, even though these are the same. If I change this number to a 3, even though these are the same, it's still a function because the only ones that matter are the x value, the domain, the first number in the parentheses. The other numbers do not matter at all, ever, ever, ever. There is no time when we care what the range is. But they may ask you at some point, what is the domain of this? What is the range of this? Okay, so they may ask you, what are those numbers? Okay, given a situation, if I said, what's the domain? You would tell me the domain is 1, 3, and 5. If I said, well, then what's the range? You would say, well, the range is 2, 4, and 3. Doesn't even have to be in order. Or whatever number happens to be at the end there. Okay? So that's what a function is. Is something a function? Now that's the first way to tell. Look at the x values. That's if they're listed. If you're given a whole bunch of points, you say, well, I'm just looking to see if the domain repeats. If the domain repeats, then it's not a function. If the domains are all different, then it is a function. That's the first one. The second one, the second way to tell is something called the vertical line test. Okay, well, vertical means straight up and down. That's vertical. That is a vertical line. We're actually going to talk about what kind of slope that is in the next lesson. But that is a vertical line, straight up and straight down. Obviously, it's a line, so there's the second word. Now it's the test. The test is, can I draw a vertical line through the whatever it is. It could be a line, it could be a squiggle, it could be anything. The graph, okay, could be anything on a graph, anything it wants to be. Can I draw that vertical line through the graph and touch it more than once? Let me give you one example of each. So if we have ourselves a little graph, there's the x, there's the y, and this graph, let's just make it easy. Nice straight line. There's the line. And the question is, can I draw a vertical line straight through this line that I just drew and touch it more than one time? Nope, I only hit it once. Nope, I only hit it once. There's nowhere I could draw that was going to hit it more than once. So since it passes the vertical line test, it is a function. Let's do one that doesn't. How about something simple? Because I can draw this vertical line straight through, and I hit this here and here. That is not a function. I hit that at the same spot 2 times with one line. And the truth is because they have the same x value, right? This is the x. Here's the x. So here we are hitting, this might be x is maybe -3. So this might be the point -3, 3, and this might be the one -3, 6. And because they have the same -3, they fail the test to be a function. And therefore, that is a function, that is not a function. And the reason it's nice to have these two different methods is, how are they handing me the data? Are they drawing, did they give me a graph that's already drawn? Then I can tell if it's a function or not. Did they give me a bunch of points and ask me if it was a function? Then I can just look at the points and just look at the x's. Are they all different? Yes, it's a function. No, it's not a function. Okay, so you have a lot of, so that gives you a couple of ways to handle that. Okay, so got a lot of vocabulary so far. So domain, x, range, y, function is this weird nebulous thing of, does it pass the vertical line test? Does it have all different x's? Don't. Now, if it doesn't, if it fails the vertical line test, it's actually not called, it's not called not a function, it's actually called a relation. And I don't want to go into a lot of detail on that because it's really about all you need. If it's not a function, then it's called a relation. Because there's still some relationship between the x's and the y's. It's just not function, it's not a function. Okay? I'm not sure why that's so important to those people that write these exams, but they really do get all excited about what is or isn't a function. Okay? All right. So the last thing that I think you're going to be asked to do is, checking. Yeah, no, I don't even know. Just knowing when you're given a bunch of domains, they're usually going to be asking you to put it into an equation, and that will generate a bunch of domains. Like I said, let me give you one example of that, and then we'll probably be done here. So let's say I want to know what kind of, how much am I going to make? And I know I work 40 hours a week. That's a normal work day for most people, not teachers, but most people, because I got all kinds of weird schedules. But, so you're working 40 hours in a week, and you want to know how much am I going to make in a week. So 40 hours, and you multiply that times whatever you make per hour. So X equals hourly pay. And that equals something called Y. Y is weekly pay. Right? Because we multiply what we make an hour, and that tells us what we make in a week. And that can change, right? So we might find that we're looking at different jobs, and we want to know, well, so how would it benefit me if I, go to job number 1? So the first job is I make $12 an hour. Okay, that's the first one. Second one would be, how about if the next one were $15 an hour? How about if I made $20 an hour? That's enough. How would each one of those work out? Well, I just plug it in one at a time. Well, Y equals 40 times 12. 40 times 12 is $480. That's 1 week. And I can write this now as an ordered pair. And we'll see this in the next lesson as well, because it's just too important. I thought little intro to you, and then we're done with it, is that this would be at $12 is $480 a week. Then we do it again. What if it's 15? That's $600. So that would be the next one. $15 an hour would be $600 a week. And the last one was $20 an hour, and that would be $800. And these might be the kinds of questions you might ask yourself when you're looking for a job and you're trying to figure out. So it might be really interesting if you try to figure out, like, maybe one of the jobs doesn't allow you to work 40 hours a week, but it pays better. And then you have to figure out, well, which job is better, which job is going to make me more money, because right now I need to make money. I don't have enough. I need more. So I need to work on the one that's going to pay me better total, even if I have to work a little bit more to make that extra money, because they allow me to work that extra money. So, and we can talk more about that at a later date. Okay, so domain is x, y is range. Okay, a function is all the x's are different, or if you're looking at a graph, it's passes the vertical line test. Okay, those are the things that I want you to be able to come away with from today. And I will see you in office hours or in class.